Assalamualaikum and a very good day. This will continue on the last subtopic of the part 3, which is the power system load. So this is the outline where we will introduce you about what is the power load, types of load, terms, load profile, load duration curve, load factor, diversity factor, load sharing, tariff, and power factors. So the objective of this subtopic is that the student should able to know at the end of this subtopic to explain the type of electrical loads, define and determine the various terms and factors in power plant engineering, explain the nature of loads and how they are met, explain, determine and analyze tariff and energy consumption and cost of consumers. So as an introduction, in our daily life, we use many forms of energy such as mechanical, heat, and also light. Electricity is special as it can be easily be transformed to this form of energy. Okay, so where as you can see, electrical can be transformed into mechanical, which is the motor, and also can be transformed into heat. Okay, water heater, air conditioner, and so on, and also light, which is the lighting. Okay, so this chapter discuss the characteristic and way of electricity being used and how to the utility, which is in Malaysia is the TNB. In Sarawak, we have the Sarawak Tenaga Nasional, okay, and Sabah. Okay, so we have actually three utilities in Malaysia. Meet these demands economically, effectively, and satisfactorily. So before we proceed, we would like to introduce you several types of loads. Okay, so we have several types of loads. For example, we have what we call residential load. So usually this type of load includes the domestic lights, power needed for domestic appliances such as radio, television, water heater, refrigerator, rice cooker, fan, small motors, and etc. And we have also what we call the commercial load. So this is a commercial building, which is a shopping mall and so on. So it includes the lighting and air conditioning for the shopping complex, office, and so on. Another type of load is the industrial load. It consists of various demands of industry. So this is more towards on the factory side. So the main loads in these sectors are the induction motor. Okay, and we have also load that categorized under what we call public lighting and municipal loads. So this is referred to the Majlis Bandaraya, Dewan Bandaraya, Kuala Lumpur, and so on. Okay, so the type of load for this load is actually mostly consists of a street and city town lighting and power required for water supply and the drainage purposes. And we have another one is which is the agriculture load. So this is more towards on the agriculture side. So for this type of load, the electrical load always referring to the motor used for the irrigation and also the lighting. And the last one is what I call the mining loads, the loads, electrical load that is associated with the mining sectors, for example, the motor for water pumping. Okay, so that is the type of load. Then we come to the the terms and definition that we will use in this subtopic. So the first term that we will actually introduce to you is actually the connected load. So what is the definition of the connected load? Is actually the connected load on any system or part of a system is the combined continuous rating of all receiving apparatus on consumers' premises, which is connected to the system or part of the system under consideration. So in general, the connected load is actually the load that is connected to the system. Next is what we call demand. So the demand of an installation or system is the load that drawn from the source of supply at the receiving terminals, average over a suitable and specified interval of time. And this demand of load is expressed in either in kilowatts, kilovolts ampere, kVA, or this one is actually apparent power, and sometimes also is expressed in amperes only. And it actually depends on the systems, okay? The next terms that we will introduce you is maximum load. So what is the maximum load, or sometimes we call maximum demand? Okay, the maximum demand of an installation or system is the greatest of all demands that have occurred during a given period. Okay, so it is actually determined by measurement. So it is not just assumption and so on, because this is based on the measurement according to the specification of the building over a prescribed interval of time. So this is very crucial, okay, when you are designing, when you are a electrical consultancy, designing the electrical system in a building. So this is one of the terms that need to be what we call calculated, very accurate, okay. Another terms is actually the base load. So it is the unvarying loads which occur almost all the whole of day on the power station. So this is actually the base load. It is the lowest load to be supplied at any time. The next term is the what we call intermediate load. So this load is categorized between the base and the peak load that have to be fed by the system. Okay, we finish on the load terms and definition. So next is actually we will actually introduce you what is the load profile, or sometimes also called the load curve. So a load curve is a graphic record showing the power demands for every instant during a certain time interval. And this graphic record can be either in recorded in 1 year. Okay, so this is called hourly load profile. It can be recorded in 24 hours, and this record we call as a daily load profile. And it is also can be recorded in 1 month, and this one will be your monthly load profile. And it can also be a 1 year record, and this is will be your yearly load profile. And please be noted that load profile will vary according to the customer type. Okay, for example, commercial, residential, and industrial, temperature, and also holiday seasons. So it is worth also noting that from this load profile or load curve, there are several points that we can actually extract, or we can actually obtain from this load profile. Okay, the area under the load profile is actually represent the energy generated in the period that has been considered. Okay, and the area under the curve divided by the total number of hours will give you what we call the average load on the power system. And the third point is that the peak load indicated by the load curve will represent the maximum demand of the power system. While from the load profile also we can actually detect what is the base load, or what is the lowest load registered during that period. Okay, so this is the graphic representation of the load profile, or sometimes also load curve. For this one is a 1 day, so this is your daily load profile. Okay, but it didn't mention whether it is resident or commercial or industrial, but I think this is resident based on the curve here. Okay, as you can see, this one from 1 a.m. to 5 a.m. there is what we call the pattern of the power consumption is very low here, and we have the lowest demand at around 6,284 megawatt. Okay, this happens at 5 a.m. but is actually increasing, okay, towards 7 to 10 a.m. here. Okay, so this is, sorry, this is the system demand. This is the overall system of the power system. Okay, so this is not residential. It's actually maybe the summation of the all loads, resident, commercial, and also industrial. Okay, so this is for a large power system. Okay, and then the peak, as you can see here, is this is the peak, which is this we will be defined as the maximum demand. Okay, and this actually the summation of all, which, or sometimes we call this one is the area, the summation, and divided with the 24 hours, it will give you a value, an average value. So this is your average value of this one day load profile. Okay, so very important. We need to know what I call the load, the base load. Okay, which is usually referred to the lowest part. We have the maximum demand, which is always referred to the peak load here, and the average. And this is the typical Malaysian residential load profile. Okay, so as you can see, so 5.5 kilowatts. Okay, and then it decreased, and around 6 a.m. The power consumption is increased, but and then getting reduced because most of the people have go out to school or go out for work, and as you can see, it is maintained below than 4,500 watts until around 6 p.m. where, as you can see, the power consumption is shoot through maximum, which is maybe around 6,300 something here. Okay, so this is actually logic, because most of the people are coming home, and that's why we have a very sharp increase in terms of power consumption. And this is actually the Indonesian typical resident load profile. So I cannot actually search the Malaysian typical resident load profile. So in the internet, I can only get the Indonesian, our neighbor countries. Okay, so this is actually the breakdown of the loads used in the typical residential for the Indonesian. As you can see, we have the lighting, refrigerator, rice cooker. I think refrigerator is the 24 hours will be functioning all the time. Okay, so as you can see, this the yellow line here, always on. The lighting is only on during the night time. Okay, the fans, we actually has a lowest consumption, but will be pick up during night time. And then televisions also, as you can see, is increased at the night time, and so on. While this one is the electrical load profile for a commercial building, so which is a contradict with the residential home. As you can see, from 7 a.m. to around 6 p.m., the load is actually very high, because most of people is actually going out for shopping or working. Okay, and this is the building total, and this is actually the breakdown of the power consumption for different type of load. So HVAC is not high voltage AC transmission. Okay, please be noted. This HVAC is related to the heat ventilation and air conditioning. So this is the load that for ventilation purpose, for example, fan and also aircon. Okay, and also lighting, we have a lift and escalator. So from the load profile, the information that can be obtained is actually give information about the incoming load and help we decide the install capacity of the power station and to decide the economical size of various generating units. Because to generate power is not, for example, if you have 4 generators, so we need to actually, we don't want all generators to produce the same amount of power because it will be not a cost beneficial for the TNB, okay? And maybe the power is actually beyond the demand. Okay, so based on the load profile, okay, the TNB can strategize which generator can turn on and which generator can be turned off during a specific period. Okay, so that it can actually uh, save the cost and so on to generate the power. Okay, so this is the next the second what we call the load duration curve. So it is actually different with the load profile. Okay, so load duration curve. So actually the load duration curve is actually represent the rearrangement of all the load that we have considered during our load profile in a chronological load curve, okay, in order of descending. So we rearrange that load in descending magnitude. For example, this is the load profile. Okay, the list load profile is showing what is the power demand. Okay, for a certain time interval. For example, from 6 a.m. to 8 a.m. the power consumption is around 18 kilowatt, and from 8 a.m. to 2 p.m. the power consumption is around 35 kilowatts, and after that around 6 p.m. and towards 6 a.m. The power is around 3 kilowatt. Okay, so this is the load profile. But the load duration curve, what we do, we rearrange this. Okay, we rearrange this in chronological load curve in order of descending magnitude, meaning that from the maximum to the lowest power demand, like this. So this is the load duration curve that the same load profile, but we rearrange from the maximum to the minimum. Okay, and as you can see here, the total time should be 24 hours for one day. Okay, 24 hours, because this is the load profile for 24 hours. Okay, so as you can see, 35 kilowatts is consumed around 6 hours, right? From AM to 2 PM, so 6 hours. So 6 hours, and then the next power consumption is the highest is a 30 kilowatt, which is consumed around 3 hours, and then next 24, 18, and the last one, which is the base load that will consume around 12 hours. So this is the load duration curve. We rearrange the load profile in the descending order. So how and what is the procedure for plotting the load duration curve? So from the data available from the load curve, okay, so we determine the maximum load and the duration of which it occurs. And then now take the next load, which is the next maximum load, and then we total up the time duration with this and the previous load occurs. And then we plot the loads against the time during which is occurred. So this is as one example, okay? So you have been given this load profile, which is from 6 a.m. to 8 a.m. The load is around 8 megawatts, okay? And then from 8 a.m. to 1 p.m., this one is around 20 megawatt. From 1 to 2 p.m., 5 megawatt. From 2 p.m. to 6 p.m. is 30 megawatt, and so on. So you are required to develop the load profile, the load curve, okay? The load duration curve for this example. So what you need to do is actually to see what is the maximum power and the duration of that maximum power. So for example, the maximum power here is 30 megawatts. So 30 megawatt, meaning that you can actually start. So this is your power, which is a megawatt. So this is hours. Okay, so you start with the maximum is 30. Okay, and then the duration curve should be around this one is 4 hours. The next is 20. The duration is this one, I think 5 hours. So the total up right now is 9. Okay, and next is 8. Okay, so as you can see here, the 8 we have from 6 from 6 a.m. to 8 a.m., which is 2 hours. And then we have another one from 6 p.m. to 6 a.m. So this one is around 12 hours. Okay, and then another one is actually 5. Okay, so we have 30, 20, 8, and also 5. So this one is around 2 hours. So the total up, you should total up here, the total up should be 24 hours. So 5 plus 5, 4 plus 5 plus 2 plus 12 plus 2 should be 24 hours. Okay, so this is actually the solution. And as you can see, this is time in percentage. So most of the time, as you can see, the load will be around 95% will be around 8 megawatts. Okay. Okay, so point to be noted during the load duration curve, what is the information that we can obtain is that the area under the load duration curve represent the total energy delivered by the generation stations, and the load duration curve actually give a clear analysis of generating power economically, and from that load duration curve also we can have a proper selection which power plant need to be on and off, okay, to meet that load demand. So we will continue on the next video on the net load factors. Okay, thank you very much for your attention.